The segments connecting the vertices of the bases are called lateral edges. So remember yesterday we talked about edges. Those were all the line segments that where the two faces would meet. All the ones on the sides are called lateral edges. So anytime really that you hear that word lateral when you're referring to prisms, you're just talking about the things in between the bases on the sides. The altitude and the height, that'll be important today. Here's what I want you to underline. Yes, it's perpendicular, but this is what's really important right there. Because sometimes height gets a little bit confusing because now that we're in 10th grade math, your height does not always go up and down. It could be left and right, it could be front to back, but it's always the distance between the bases, and it is perpendicular. And then we have two different prisms called a right prism and an oblique prism. So a right prism stands straight up and down. It has your lateral edges are all perpendicular to your bases, and then an oblique prism is where it is slanted. And then on those oblique prisms, you have what's called a slant height. Because you have slanted sides, it would be the height of those sides. Now, the slant height is not terribly important with prisms. It'll be more important with pyramids. Because for our purposes, for surface area and volume in this class, we only deal with right prisms. So the slant height isn't terribly important. Okay, so there's kind of an anatomy breakdown of prisms. Let's just real quick review this. When I typed this up, I didn't remember that we had already gone over this the day before. That's okay. Let's review this. These are all different types of prisms. And remember, you name prisms by the base shape. So this first one, who can raise their hand and tell me what that prism would be? CJ? Triangular. Here are your bases, kind of in the front and back. That would be a triangular prism. This one here looks like a cereal box. What kind of prism would that be? Jacob? Rectangular. And on that one, I don't really know which the bases, the bases would be these little skinny ones. Down here, the third one. Riley? Careful. 5 sides. Pentagon, pentagonal prism. And then this last one, Louis? Hexagonal prism. Good. Quick little refresher to yesterday. We named prisms based on this, the shape of their bases. Okay, let's talk briefly about surface area and what surface area is in general. Surface area in general is the area all around the outside of the shape. So like this hexagonal prism right here has 8 different faces on it. It has a top, it has a bottom, and then it has 6 rectangles around the sides. So your surface area, in general, is the area of the top, the area of the bottom, and the area of all 6 rectangles added together. Over here with the pentagonal prism, that would be the area of the pentagon on top, the area of the pentagon on the bottom, and then all 5 of the rectangles around the sides. If you added all those areas together, then you would get your surface area. We used to talk about what's called nets and get the surface area that way. We don't look into that anymore, but you know, if you've ever taken like a 3-dimensional paper sack and made a book cover out of it, you know how you like cut it and then lay it out flat? That's what's called a net. And so if you were to find like the area of each piece of your paper bag and then add it all together, that's what the surface area would be. I always refer to as well, like if I were to wrap a gift, if I were to wrap this box of cereal looking thing, the wrapping paper would take up the surface area. And so that's why on a lot of wrapping paper nowadays, you see little squares on the back because they're calculating area of how much wrapping paper you need. So think of surface area as like a wrapping all around the outside of your figure. Now, instead of having to find the area of every single shape and then add them all together, we have a little bit of an easier formula. First thing we have to remember too is that the bases of your prism are congruent to each other. So if I can find the area of one of the bases, I've found the area of both of them. So our formula in general is, for surface area of any of these polyhedrons, you have two bases, and then you have all of your lateral faces. So your formula is area equals two of the bases, two of the areas of the bases, plus the perimeter times the height of the figure. And that takes care of the two bases, and then the perimeter is everything around the base. So I know you guys don't have this kind of laid out as nicely as I do, but here's what I would write down. B, so I can just actually skip that, that's fine, and then write it like you guys would write it on your sheet. B is the area of the base. Now, you can see these up here, right? The area of your base depends on what the shape is, because how you would find the area of a pentagon is not the same as how you find the area of a rectangle, which is not the same as how you find the area of a triangle. So this capital B depends on the shape of the base. Whether it's a triangle or whether it's a hexagon or whether it's a trapezoid, you find the area of those shapes all different ways. So it depends on what that shape is. So I'm going to leave those formulas up there. Your capital P is the perimeter of the base. Perimeter of the base is capital P. And then H is your height of the shape. And so remember, back on the first slide, height is the distance between the bases. It does not have to be up and down, but it will always be the distance between the two bases. I should have added, you're going to see this a lot, sorry, I should have added an S in front, surface area, as opposed to just area. SA, if you ever see that on homework, that stands for surface area. I put it on tests usually too. Okay, super important that you write down what the variables stand for. So if you haven't done that, you need to do that right now. Okay, volume, you don't need to write these down. Volume in Cavalieri's principle. Volume is everything inside. So surface area is everything on the outside, like if I were to wrap a gift, and volume would be like if I was filling something. So there's usually at some point in your education a water tank problem, and that might be more science, where you're filling a water tank. Volume is everything on the inside of a shape. So if it's, and you can't have volume for two-dimensional figures, they have to be three-dimensional. So the very first volume formula you guys ever learned was for cubes. When you do base times width times height, or length times width times height, that would be an example of volume. This principle right here just says that the volume of an oblique figure, so one that is slanted, has the exact same volume as a right figure, as long as the bases are the same size and as long as the heights are the same distance. So if you happen to see a slanted figure, the volume of it is not going to be any different. You'll still calculate it the same way, even though it's slanted. So here's your volume formula. Volume is a little bit easier. That's just capital B times H, and they stand for the same thing. So if you want to rewrite it down, you can. B is area of the base, and H is the height. And so, when you guys first learned volume a long time ago, the first formula you guys ever learned was length times width times height. And that's because length times width is the area of your base, that's your capital B, and then height would be your h. And so just now, you're not limited to only rectangular prisms, so that capital B is the area of whatever the shape is. Could be a trapezoid, could be a triangle, could be anything. All right, we got 4 problems here that we're going to find the surface area and volume for. Also, Mrs. Dribble, I've written down that this one had a mistake on it, but it actually didn't when I figured it out this morning. I don't know what I was thinking. All right. So we have, here's our formula. Let's do surface area first. Surface area formula is 2b plus ph. 2 areas of the bases plus the perimeter times the height. So capital B is the area of your base. Let's start there. What's the shape of the base in this first problem? Shape of the base in the first problem. Okay. Those are triangles. So we have to go over here to area of a triangle, and we're going to find the area of those bases. So here's our triangle. But the area formula of a triangle is base times height divided by 2. So our base and our height are 3 and 4, and then divided by 2 gives us what? 6. Okay, because if you were looking at this 2-dimensionally and you were looking straight down on it, you would see a triangle that looks something like that. And the way you would calculate area of a triangle is base times height divided by 2. Okay, there's your capital B. Your capital P is the perimeter of the base. Now, they don't write in this side right here, but this is an example of a Pythagorean triple, a 3, 4, 5 triangle. So if this side's 3 and that side's 4, we could go through and do Pythagorean theorem to find the third side, but I'm telling you right now you would get 5. I don't think I have any on your homework where you'll have to do that. So this side right here is 5. So what's the perimeter of the base? 3 plus 4 plus 5. 3 plus 4 plus 5 is what? 12. Okay, there's our capital P. We got 2 variables. Our third variable, the height is the distance between the bases. So what's the distance between the bases? 2. And I don't want to promise you that you'll always use every single number, but usually if you haven't used a number, that's probably your height. And then we just plug it all in. So from there, our surface area is 2 times, there were 2 bases with an area of 6. Our perimeter of the base was 12. Our height was 2. And then we just type it all in and simplify it. So 2 times 6 is 12. 12 times 2 is 24. 12 plus 24 is 36. And this is area, so area would be units squared. I did that all mentally, so if I made a mistake, let me know. I definitely made a mistake on my key. 2 times 12 is not 48, it is 24. Okay, volume is just a different formula, but you actually have all the variables that you need. Volume is just the area of the base times the height. The area of the base times all of the height that it takes up. So your area of your base was 6, and your height was 2. 6 times 2? 12. And then since it's volume, volume is only for 3-dimensional figures. It's units cubed. And there's no rule as far as like, will surface area always be bigger? Will volume always be smaller? There's no rule towards that, just so you know. Okay, let's do another one. So surface area, 2 of the bases plus the perimeter of the base times the height. Okay, our capital B, the area of the base. What's the shape of the bases in this next problem? What's the shape? What's the shape of the bases in the next problem? trapezoids. Okay, so I'm just going to highlight right here. You don't have to, but I'm going to highlight. This is our base. That's what we have to find the area of. Area of a trapezoid is probably a formula you haven't seen in a while, so it might be worth writing down. This is your area of a trapezoid. Base 1 plus base 2 times the height divided by 2. You have learned it a long time ago, we just haven't seen it in a while. Okay? So you have two different bases. They're both different sizes. One of your bases here is 4. This one's kind of labeled in a weird spot. How long would this length be right here? 7 is correct. Because this is a rectangle up here, if this side is 7, then this side is 7 as well. Good. So our two bases are 4 and 7 times just the height of the trapezoid, not the height of the prism, just the plain old height of the trapezoid. So just try and ignore all of this behind it. What's the height of the trapezoid? 3.7. And then divided by 2. So again, it'd be like if I was looking just only at the base, you would see a shape that looks something like this with a 7, a 4, a 3.7, and then these two sides over here would be 4 and 4. But we can talk about that in a second. 4 plus 7 is 11. So 11 times 3.7 divided by 2. 20.35, Riley says. Okay, that's your capital B. Capital B is the area of the base, whatever shape the base may be. It's not just like a single number that you pick off of the picture. Capital P is the perimeter of the trapezoid. Now this one is a little bit harder to see as well just because of these two sides. This is 7 right here. This is 4. This side and this side have tick marks, meaning they're the same, and they have the same tick marks as these sides over here. So if those are 4, then those are both 4 in the front. So then your capital P, your perimeter of the base is 4 plus 4 plus 7 plus 4. 4 plus 4 plus 7 plus 4. That's the 4 different side lengths around the trapezoid. 4 plus 4 plus 4 is 12, plus 7 is 19. There's your capital P. And then your H is the distance between the bases, the distance between the trapezoids. What's the distance between the two trapezoids? 6. So here's your capital B, here's your P, and here's your H, and then we just plug them all in. 2 times 20.35 plus 19 times 6. 2 times 20.35 is 40.7. 19 times 6 is 94. No, 114. And then 114 plus 40.7 is 154.7 meters squared, because it's area. Your volume formula is area of the base times the height. The area of the trapezoid was 20.35. And the height between the trapezoids was 6. 20.35 times 6 is 122.1 meters cubed because it's volume. Any questions at this point before we do the next two? I know it's kind of hard to pinpoint questions in a section like this, but... Okay, let's move on to a rectangular prism. Oh, this one's so much nicer for us because rectangles are pretty easy to work with. So our surface area formula, 2b plus ph. Our capital B is the area of the base. Your bases are whatever you only have two of, which in this case would be any of the sides. So it really doesn't matter what you choose as the base in this problem. I can choose the bottom rectangle as the base, that's fine. Rectangular prisms are kind of special. Like, it doesn't really matter which one you choose as the base. The area of a rectangle is base times height. So base times height, 3 times 6 is what? 18. Okay, there's your capital B. Boom. The area of the base is 18. Your capital P is the perimeter of the base. Now remember, your base looks like this at a two-dimensional standpoint, where this is 6 and this is 3. What do we know about opposite sides of a rectangle? They're the same. So if this is 6, this is 6. If that's 3, that's 3. So perimeter is 6 plus 3 plus 6 plus 3. 6 plus 3 plus 6 plus 3. 18, right? That's weird. Same area and same perimeter. And then your height is the distance between the bases. So in this case, it would be the up and down height. And how much is that height? 4. And then plug it all in. If that's 4, then this is 4. 2 times the area of the base is 18, plus the perimeter is 18 of the base, and then 4 is the height of the prism. Two times 18 is 36. 18 times 4 is 40 minus 32? No, was it? 72, thank you. And then plus 36 is 108 feet squared. And then volume is just area of the base times the height. Now for a cube or for a rectangular prism like this, it's literally length times width times height. So our area of the base is 18 times the height is 4. What's 18 times 4? 72. Okay, no, Riley can't answer anymore though. Thank you though, Riley. 18 times 4. Did we all type that in? 18 times 4. 72 feet squared, or feet cubed, excuse me. So I want to stress to you again, where's your note sheet? That the capital B and capital P depend on what the base is, what shape the base is. Like this one. This one, what shape are the bases? Pentagons. And so area of a polygon, any kind of polygon, is what we did in 11.3, apothem times perimeter divided by 2. So area of a pentagon, or any, so that would, you would be using this formula if it's a pentagon, hexagon, octagon, anything that has more than 4 sides, essentially, and is not a trapezoid. So apothem times perimeter divided by 2. That's going to be our capital B. So again, it's kind of like you're looking at a pentagon. I could draw one that would be good, where the apothem is 5.5 and all of the side lengths are, how long are these side lengths? Can you guys see that? How long are those side lengths there? 8. And they're all 8. Okay, so your apothem is 5.5. The perimeter of your base, is 8 times 5 sides. this is the height between the bases. So we'll get there. We're just looking at the two-dimensional pentagon right now. So what's the perimeter of your pentagon? 8 times 5, folks. Jacob? 40. And then divided by 2. 5.5 times 40 divided by 2. 110. There's your capital B. Your capital P you already found. Your capital P is the perimeter of the base. You already found that. It was this number, 40. 8 times 5 sides. And then your H, your height, is the distance between the bases. The distance between the pentagons is 6. So capital B, again, is the area of the base. Capital P is the perimeter of the base. Not of like the entire shape or anything, just of the base. So if it helps you to redraw the base on its own, not in a three-dimensional figure, you could do that. Surface area, 2 of the bases plus the perimeter times the height. So 2 times 110 plus the perimeter is 40 times the height of the figure is 6. I get 220 plus 240, which is 460 kilometers squared. And then your volume is just capital B times H. Your capital B was 110. Your height was 6. 110 times 6, 660 kilometers cubed. So I know I'm like a broken record, but your B and your P depend on the shape of your base, specifically the B. Okay, last question here. So those were 4 examples that each had a different shape of the base. And so you can see that your capital B, they were all solved differently. The first one was a triangle, base times height divided by 2. The second one was a trapezoid, base 1 plus base 2 times height divided by 2. Then you had a rectangle, just base times height. Then you had a polygon, apothem times perimeter divided by 2. So those area formulas are going to be really, really, really important for you to know, because that's what depends on what your capital B is. This last problem says you're building a rectangular chest and you want the length to be 6 feet and the width to be 4 feet. The volume is to be 72 feet. What should the height be? So your volume formula is the area of the base times the height. I want the volume to be 72. What would the area of the base be here? Base times height. 6 times 4, 24. And then I want to know the height. I like this problem. It's a pretty applicable problem. Like if you know you want something to hold this much stuff in it, or this many cubic whatever feet or inches or whatnot. Trying to figure out how tall to build it. Divide by 24, and what's 72 divided by 24? 3. So we should build this chest to have a height of 3 feet. If I want it to hold a certain amount, and then have a certain width and length dimension. Like if I had a spot in my room where I only had 6 feet of length and 4 feet of width to spare. Okay, your homework is the 11.5 worksheet, but it's only the prisms side. Let me make sure I don't have any mistakes on it either. So it's only the front. And I chose examples that are really like the ones in your notes. Like I chose one triangle problem, one rectangle problem, one trapezoid problem, and one polygon problem.